start with penetration testing. Now, vulnerability assessment and penetration testing are used in conjunction very often. We'll take a look at the difference between both. We'll also see what are the types of security tests, definition of a PT, and why we should conduct a penetration testing, what the legal issues are while conducting a PT, and some of the popular tools related to PT. Now, this module will familiarize you with what a malicious hacker does, what are the types of security tests, what is a penetration test, why do you need a penetration testing on your infrastructure, what are the legal aspects of penetration testing, then vulnerability assessment versus penetration testing, how do you conduct a penetration testing, and what are the tools that are used for penetration testing. We'll see what a malicious hacker does. Now, if you look at the image on the right hand side, you'll see there are 5 phases. The first is reconnaissance, the second is scanning, the third is gaining access, fourth is maintaining access, and fifth is clearing tracks. Under reconnaissance, we have active reconnaissance and passive. Then there is scanning of ports, services. Then, after identifying the vulnerabilities in the second phase, the attacker tries to gain access at the operating system level, at the application level, at the network level, probably cause a denial of service. Then he maintains the access in the fourth phase, where he can upload, alter the existing files, or download confidential information. That information can be programs, can be data. Then finally, he clears up the tracks so that there is no evidence of him penetrating the network. What is the perspective of an adversary? There are 5 phases here. In reconnaissance, when you look at the slide, it is web-based information collection and social engineering techniques. What is web-based information collection? If there is a site hosted, the adversary or the perpetrator tries to find more information on the site. What is the public IP? What is using IP tools or network tools or DNS tools, or simply trace route, how many hops are there to reach the particular server. Then social engineering techniques. He tries to engage an internal employee of the company using false pretenses, try to gather as much information as possible. It can also be through dumpster diving. We have discussed that earlier. Then comes the scanning, where a broad network mapping is used. So tools such as Nmap, Nessus are used. And it's a targeted scan to a specific IP within the network or specific server. Then the system access, where service vulnerability exploitation, suppose it is there that Microsoft has got a particular flaw in this particular port or service, and it can be exploited this way. If it is mentioned under a CVE, the attacker tries to penetrate that or exploit that particular vulnerability. He does a password cracking phase using different tools like LOPHT crack, John the Ripper. So several tools are available for that. Then the actual damage happens. He can cause a DDoS attack. He can install a code within the server for causing havoc later on. The attacker can delete a system file, so damage has been done. He maintains the access. Then he clears the tracks, that is use of stolen accounts for attack. He changes the log file to erase the evidence of him coming in. So these are the steps that are done by a potential attacker. Now, the first three phases, that is the reconnaissance, scanning, and system access, is where the preventive phase comes in. So you can actually, with the help of different methodologies, different tools, you can provide a defense for this, which is a real-time or proactive security. Now, in the next two phases of the penetration testing, there is a report that comes out of the penetration testing. So the organization, based on the report, will implement the recommendations. This is a reactive security or an incident response. What will happen if an attacker does the first 3, 4, and 5? What happens? So from the penetration testing perspective, when a person who is authorized to conduct a penetration testing finds out all this and gives a recommendation, the organization implements those measures so that in the event of a real attack, the systems are not compromised. There are different kinds of or types of attacks. The ways an attacker or a hacker use to gain access to a system can be classified as, so there are several ways and methods that a hacker can get into the network or access a system. Operating system attacks are one, where the attacker looks for the operating system vulnerabilities via scanning phase, where he sees what are the open services, open ports, what are the methods of access, and exploits them to gain access into the system. Then there is application level attacks, such as your programming errors, your buffer overflows. All these are examples of your application attack. So he exploits these vulnerabilities to do an application level attack. Then there is a shrink wrap code attack, which is basically the OS or application which contains sample scripts for administration, which comes default shipped with the system. For example, if you have IIS web server which is you have installed, there will be certain scripts which are by default enabled in the system. So you have to go and make the settings. So you should not allow the default installation to remain as it is so that the attacker can gain access. Similarly with PHP installation or Apache installation. Now, if these scripts were not properly fine-tuned, then it will lead to default code or shrink wrap code attacks. That is, you exploit a vulnerability which is known to you because proper settings have not been done on the server, on the web server. Then there is misconfiguration attacks. Most of the times, the developers or the implementers fail to change the default settings. So then if it stays in the default settings, then attacks can be done on that because they were not configured properly. This is a simple example of how the vendors actually plug holes. Now, Microsoft plugs Windows wormholes. So there were 14 flaws in a particular version of Windows, including a security hole that one expert says is ripe for exploitation by a major worm. So the details are given in this slide. So this is an example for you to understand that once a vulnerability is found, the attackers try to exploit it. They find out the means and methods to exploit that vulnerability through different factors. Now, in this particular instance, because of a security hole, an expert has found that a worm could actually attack that or exploit that vulnerability. And Microsoft Windows has released security patches for that particular vulnerability. So it is a constant process. There will be a vulnerability found out in a product or service. Somebody will try to exploit it. Then the operating system vendor will bring out a fix or a security patch for that. Once that patch is applied, then that particular attack can no longer happen. But the attackers will still have methods to get into the system using other vulnerabilities. The main weakness found in the networks are many of the systems or servers in the networks are not patched properly. Ultimately they blame it on the operating system vendor. So as and when a patch is released, it is recommended that you install the patch, secure your infrastructure. But many of the hacks that happen, if you see the background of the hacks, you will come to know that an outdated version of Windows 2003 server was used, where the latest version is 2012. Or a Windows XP machine was targeted when the latest is Windows 10 is coming in now. So basically, the reason for exploitation is again from the human perspective, that the systems are not updated on a regular basis, because the developers may sometimes feel that by installing this patch our software will not work. So I have seen instances where the browser was in a application where the application works only on Internet Explorer 6, where the current version of Internet Explorer at that time was 7 or 8. So flaws in 6 could have been exploited by attackers. Majority of the problem is that organizations or the team that handle security do not implement the security patches as and when they are released by the operating system vendor. So they often blame the vendor or the maker of the product for the vulnerabilities that exist. Or they say that, no, by installing this patch, my system will not work. So the customer also does not know what to do. So there are several issues. Ultimately, it is a people problem and a process problem where security measures are not being followed diligently by the organization. This is another example which is because of a misconfiguration facilities or a misconfiguration which facilitated a worm outbreak in London hospital. Again, misconfiguration, we spoke about it just a few seconds ago. People fail to understand the implications of the security issues. Security is only the last option for organizations. They say my priority is not security. My priority is to see that I develop this software and sell or implement. So more often than not, you find that most of the software developed are of poor quality, which do not have proper security implementation because they don't involve security experts in the design phase itself. And then they spend a lot of money for rectification once a hack has happened, or once it is made mandatory by a regulatory body that you should have your software audited, only then we will purchase. So then they wake up to the fact that security is an aspect. But in an Indian scenario, secure coding is never followed because the developers do not want to waste time. Second, they don't know the implications of having a secure software or secure framework in place. By closing this particular thing, what will happen to my software, whether it will work or not. So the involvement of security teams are also not there. Even large organizations where we have seen the Chief Information Security Officer talks quite a lot but doesn't know technical aspects. More often, he just handles the processes or documentation part and is clueless about what actually is happening within the network. What are the techniques for security testing? There are network scanning, vulnerability scanning, password scanning or cracking, review of logs. It can be a manual review of log which is very monotonous, or it could also be through a SIEM tool, SIEM tool. Then there are integrity checkers, then virus detection, var driving and var dialing, then of course penetration testing. Now several of these testing techniques are used together to understand or gain more comprehensive assessment of the overall network security posture of the organization. So by doing a combination of this, the organization knows where they stand vis-a-vis the security requirements. So here there is something called an integrity checker, because it's very difficult to compromise a system without altering a system file. So this file integrity checkers become an important capability in the intrusion detection systems. The file integrity checker computes a checksum for every guarded file and stores it in its database. At a later time, one can compute the checksum again and test the current value with the original computed value. But one of the problems of using a file integrity checker is that there can be a lot of false positives. So when you update files or apply system patches, this changes the file, right? It changes the checksum, it changes the hash. So it should be constantly updated to prevent the false positive problem. There are several integrity checkers. Tripwire is one of them. You can Google Tripwire and learn more about integrity checkers, what the Tripwire tool itself does. What are the methods for security testing? So every organization uses different types of security testing to validate the level of security on its network resources. If you see that on the right, the arrow goes, that is your OS STMM, and hands-on audit is very thorough. Accurate is your penetration testing, ethical hacking, vulnerability scanning. This is basically taken from the OS STMM's slide. In 2001, ISC COM, that is Institute for Security and Open Methodologies, started with the release of OSS TMM, which is the Open Source Security Testing Methodology Manual. It was a move to improve how the security was tested and how it was implemented. Many researchers from various fields contributed because they saw the need for an open method, the one that was directed towards the truth and not for commercial gain or for political agendas. And it's not enough to just find the facts. We need to find ways to apply those into the world that we live in. So, it needs to be a security philosophy and it needs to make sense. And that's what ISCCOM did by bringing in OSS TMM framework. Now it helps millions of people around the world, from governments, to businesses, to schools, and to regular people like us, so that we can make better sense of what security is in the real world. Now we'll see what is penetration testing. It is a method for evaluating the security of a computer system or a network. Network is a collection of computers or devices by simulating an attack from a malicious source, from a source which is not authorized to come into the network. This process involves an active analysis of the system for any potential vulnerabilities that may result from poor or improper system configuration. So here you have to note, one is evaluate the security. It is in red, simulating an attack. Poor or improper configuration. Known or unknown hardware or software flaws. Operational weaknesses, which is the processes that are followed in process, or technical countermeasures. And what is the intent or intention of your penetration test? It is to determine feasibility of an attack, whether the attack can happen and the impact that can be caused by that attack being materialized. So that is what is penetration testing. So what you need to understand is, it's a method for evaluating security by simulating an attack, by testing for vulnerabilities because of improper or poor configuration, unknown or known hardware or software flaws, or through an operational weakness, and to determine feasibility of an attack, to see what is the impact on the business